All right, last section of chapter 12 is going to be 12.8. Change of variables. In multiple integrals. Okay, so let me preface this by saying you have done change of variables before. Okay, you have done it when you do use substitutions, and you have done it when we convert rectangular coordinates to polar coordinates. Okay, so it's not new. It's just that you haven't done it in the way that I'm going to show you how to do it. So we're going to get into some of the little bit more of the theory behind it, things that might seem a little bit more abstract to you, okay? But once we get to the examples, this is one of those lessons where I feel like I'm going to show you some stuff, but when you see the examples is when it's really going to make sense, okay? Hopefully. So the background here first, if you're feeling a little bit unsure, a little bit lost, don't get too concerned. Just hopefully it'll all come together when we get to some of the examples. Okay, so the first thing that we're going to talk about is why we would change these variables. Okay, well, actually, back it up a little bit. Some of the notation here. Okay, so we might have something that's in your UV plane. Okay, we might have this figure S. Okay, and we have points in S, then that would be like U1, V1, U2, V2, oops, V2. Okay, so we got these points in S. And we might want to transform it to a different coordinate system that's easier for us to work with. Okay, maybe under some sort of transformation, S becomes a circle. Okay, S becomes R. And U1, V1 becomes, oops, I think we're going to call this X and Y. X1, Y1. Okay, and U2, V2 becomes X2, Y2. Okay, so these points undergo transformations and it ends up creating a different shape. Okay, we would call this forward transformation T, and we can also transform it back using the inverse of T, your inverse transformation. Okay, but T is a function that maps UV onto XY, and the inverse of T then would map XY onto UV. Okay. And then also X would be some function of U and V, and Y would be some function of U and V. Okay, and then we would use a capital letter to represent the inverse. U would be some function of X and Y, and V would be some function of X and Y. Okay. We'll have some assumptions here that we're going to make. That we're going to assume that this is what we call a C1 transformation, which means G and H, those transformation functions that map U and V onto X and Y, they have continuous first order partial derivatives. Okay, and that's not something that's difficult for us to achieve there. Okay, we would have xi, yi is the image of ui, vi. Okay, which would mean then that r is the image of s, but under whatever this transformation is. Oops. Okay. And when we say t is 1-to-1, if no 2 points have the same image, okay, and what that basically means is, we couldn't map U1, V1, and U2, V2 onto the same XY. Okay, they wouldn't end up in the same spot. So that allows us, just like one-to-one in 2 dimensions, it means that we can do an inverse transformation then. Okay, so let's look at a little bit of an example here. This example is actually kind of going a little bit backwards. They take kind of a nice figure and make it a less nice figure, but that's okay. I believe this is number 8 in your book. Let me double check. Yeah. Okay. So this is exercise 8 in your book if you're following along with the book. So S is the square bounded by U equals 0, U equals 1, V equals 0, and V equals 1. Okay, and we're asked to find the image under the transformation x equals v, y equals u, 1 plus v squared. Okay, so first of all, let's draw our square in your UV plane. Okay, so there's our square. All right. Let's just take a side of it. Okay, so oops, and I'm going to draw my XY plane to the right so it's ready for me. Okay, so let's take the bottom of this. Okay, so let's take the bottom of your square where that's the boundary v equals 0. And it goes from u is 0 to u is 1. Okay, so that is the function that would describe the bottom here. Okay, and I'm also going to draw an arrow on here because we're going to see that the orientation could possibly change. Okay, so under our transformation, okay, x equals v, so x equals 0. Okay, y equals u. I'm going to do 1 plus v squared. So since v is 0, y equals u. Okay. Furthermore, since u is between 0 and 1, y is between 0 and 1. Okay, so we have made our transformation there. Okay, x will equal 0, y will equal u. I guess I shouldn't say that. I should say y does equal u. Okay, but that means then that y is between 0 and 1. Okay, so x equals 0 and y goes from 0 to 1. Okay, so there is that piece transformed under a transformation there. Okay, we'll do another side here. Another side, let's use this guy here. Okay, let's do the top. So the top here, okay, this is where x equals 1. I'm sorry, v equals 1. Okay, and u is going from 0 to 1. Okay, so there we go. Okay. All right, so then our transformation here, x equals v. Again, we're just going back to, I'm sorry, we're doing the top here, which v equals 1. We're just going back to the transformations here. okay? So if v equals 1, then now x equals v, so x equals 1, okay? Y will equal u times 1 plus v squared. So y will equal u times 1 plus 1. Okay, so y is 2u under this transformation. All right, so that means that since u is between 0 and 1, y is between 0 and 2. Okay, so now we're over at x equals 1, and y goes from 0 to 2. Okay, oops, that's a little messy. I'm trying to make it darker here. Okay, and then the transformation has that orientation. Okay, let's do another one. Let's take the left side here. Okay, so on the left-hand side, that is our boundary where u equals 0 and v is between 0 and 1. Okay, so u equals 0. Again, now x equals v. So x is going to give us our limits over here. X will be between 0 and 1. Okay, and y is u times 1 plus v squared. Okay, so y is 0. Okay, y is 0 and x is v. Okay, so we've got that range of values that x will take on, and y is just going to be 0. So we're right here. Okay, and then x is between 0 and 1. Okay. And then finally, our last one, we're going to do the right-hand side. Okay, and on that right-hand side, u is 1. And v is between 0 and 1. Okay, so x is v, so that means x is going to be between 0 and 1. And y is u times 1 plus v squared. So y will equal 1 plus v squared. But remember, x is v. Okay, so y is 1 plus x squared, where x goes from 0 to 1. Okay, so 1 plus x squared, that's your parabola, opens up, shifted up 1 unit, goes like this. Okay, and then your x's are between 0 and 1. Okay, so there you have it. Okay, and what you might see too is that we try to make the orientation go around. So you might flip like the yellow and the green ones, you might have it go this way. Shoot, I'm trying to draw on lightly. You might switch it to go this way and this way. So we would switch it on the right-hand side to go this way, and then it gets you that like orientation around the figure. Okay? But that's the basic idea here, is that we might change between these two. We're more likely to change from the one on the right to the one on the left. Okay, the one on the left is much easier figure to do any sort of calculations with, but that's the idea behind how the transformations work. Okay. All right, now we're going to look at some that are a little bit different. Okay, I believe the next one is exercise 11 in the book. Okay, we have R is bounded by y equals 2x minus 1, y equals 2x plus 1, y equals 1 minus x, y equals 3 minus x. Okay, now what did they ask us to do here? Find the equations that will map it into a rectangular region S. Okay, so basically, they want us to take this R, map it into a rectangle in the UV plane or UV coordinate system. Okay, so let's draw what we have first of all. We have y equals 2x minus 1. Okay, oops, I guess I should make some y-intercepts that are a little bit lower. Okay, so we've got y equals 2x minus 1. Okay, y equals 2x plus 1. Okay, y equals 1 minus x. And y equals 3 minus x. I'm off by a little bit there, I think. I think I got it. Y equals 3 minus x. Okay, and what we want is in UV, okay, our goal is to get some sort of rectangle. Okay, it may seem intimidating at first. And kids always are like, well, can we do a rotation? No, you can't do a rotation. You have to do some sort of just transformation with functions. You can't just say like, let's rotate it and then you'll have it. And I might explain this a little bit different from the book. I think the book makes something that should be a little more intuitive, a little bit more complex. So with these guys with the parallel lines like this, it actually works out to be really easy. Okay, take the two that are parallel to each other. We have y equals 2x minus 1 and y equals 2x plus 1. Okay, so just change that to y equals 2x plus u. Okay, where u is between -1 and 1. All right, and I know we still have the x in there. We're going to get there. Okay, we also have y equals 1 minus x and y equals 3 minus x. Just change that to y equals v minus x. Okay, so that's all we're doing there. They're parallel, and we're replacing the intercepts with something else. Okay, and then for this one too, v is between 1 and 3. Okay, and from here it's just a matter of substitution and different ways that you can sub for it, but we want to have a v equals and a u equals. Okay, so what I'm going to do here is I'm going to set them equal to each other. Okay, so 2x plus u hold on, equals v minus x. So 3x is u minus v. I'm sorry, v minus u. Okay, let me get that. Three x is v minus u. So x is 1/3 v minus u. Okay, so now what we can do is we can take this first guy here and we have solved for x. Okay, so we can do y equals, wait, is that really what I do? Let me think here for a second. Oh yeah, we want to do, I'm trying to think here for a second because I was in the xy plane. Yeah, we're going to do y is 2/3 v minus u plus u. Okay, so we just replace the x with the 1/3 v minus u. Okay, so y will be 1/3 2v, and then it'll be minus 2u plus u, so minus u. Okay, I think I got it. There we go. And then I'm just checking my work here. I feel like I missed a negative there. Hold on a second. I don't think I did. Okay, I think I'm good. All right. Then we can do something similar with, I'm sorry, we have x then is 1/3 v minus u. Okay, so we can sub them in then. Okay, so what we have here, I just lost my train of thought. You know how sometimes you think you're on your way with something? Yeah, I'm good.